I'm sure you've all heard a lot about AI, but what is AI? What's the best way to leverage AI? And how do you evaluate all the potential AI solutions in front of you? So it starts with understanding what AI is and what it can do. So we're going to take you through a brief history of AI to explain how we got to where we are today. So the term artificial intelligence was originally coined at an academic research in 1956. And that led to the emergence of AI research as an academic field, and initially primarily funded by government. Technologies like neural networks and machine learning were originally experimented with in this time period. And there was a lot of excitement about AI, but by the early 1970s, it was pretty clear that progress was slow. There were no real practical, real world applications that were emerging from this field. And so interest waned, funding dried up, and we entered what we refer to as the first AI winter, where the term artificial intelligence declined in popularity. In the early 1980s, there was a bit of a revival of interest in artificial intelligence driven by a couple of things. First of all, supercomputers were introduced and they solved a number of the computational limitations that we had previously. And certain systems based on AI principles called expert systems were finding some commercial applicability. So real world success there with expert systems. However, the commercial success was limited, and the core AI problems of speech recognition, computer vision, face recognition were still largely unsolved problems in any general sense. And that led to what we call the second AI winter, where once again, the popularity of the term artificial intelligence sort of waned, and AI researchers diverged in a number of different directions. One of those directions was machine learning. A lot of, machine learning has always been part of artificial intelligence research, but machine learning on its own is an interesting technology because it's a lot more practically oriented than intelligence without all the philosophical weight of trying to understand what we mean by intelligence. Machine learning deals with well-defined transformation problems, meaning that I have a system that I take X as an input and I produce Y as an output. And how do we do that using machine learning? Meaning, how do we program that by example? And so machine learning became more of a dominant term in the research community, and that continued on through today. A number of technology advances were happening at the same time that brought us to the breakthroughs that we're benefiting from today. The first was the continued Moore's law trajectory of compute power, including advances in CPUs, GPUs, memory, and storage that allowed us to do large computations, store a lot of data, and also the exponential growth of the internet, which allowed us to be connected with a lot of data. So all of those things together allowed us to build large computational systems in the cloud that could collect data, use data, and do the computing that you need to develop sophisticated models. And in particular, machine learning applied to deep multi-layer neural networks, known as deep learning, by the year 2013 was outperforming every other approach to the classic AI problems of speech recognition and face recognition in particular. They brought those technologies from being primarily academic pursuits and very limited real world applications into, mainstream, widely available and widely reliable, commercially viable solutions. That is the era that we are in today, where this key technology of machine learning along with deep neural networks is enabling solving a lot of automation problems that 10 years ago felt like really difficult problems to solve.